Good evening everyone, myself Gautam Sharma. I welcome you all in Sapiens Education. For more details, you can go in a description section. There is a link provided below for our apps. So there you can also go get more information about the courses. So let us consider a circular motions. Okay, what is circular motion is? So I am going to teach you. It is a part of a motion in a plane. Okay, so briefly we will discuss about the circular motion. So when a particle moves in a plane such a way that its distance from fixed point remain constant, then its motion is called circular motion with respect to its fixed point. For example, see here, with respect to fixed point, when this object is moving, when this object when this is moving, what is happening? See, every time there is a equal distance, and this locus is known as circle. Okay, so let us C is considered as a center, and R is the radius of the circle. Okay, I hope you have understood. R is the radius of the circle, right? Now let us consider angular displacement. See, we have already seen that when an object is moving in a straight path, so we are telling that it is your linear displacement. But as it is moving in a circular path, so what we will call this? I will call this as a angular displacement. Because here angle is changing with respect to a reference line. Okay, so an object is moving in a circular path. An angle traced by the position vector of a particle moving with respect to some fixed point is called angular displacement. So see here, actually here displacement is in the form of angle. So we should take here as an angular displacement. We cannot take a distance as a x, because here only angle is changing. Okay, so angular displacement is considered as a theta. Okay, so this is the theta and this is an angular displacement. So angular displacement theta can be written as arc length by r. Why so? Because let us consider, for a very small angle, we will use this concept. Okay, we will use this concept. So for a small displacement, this is a theta. So tan theta can be written as perpendicular by base. So this is your perpendicular and this is your base, that is your radius. So perpendicular by radius. So actually perpendicular is the arc PQ. So for a small angle, we can take as arc PQ divided by arc. So that's why theta is equal to length of the arc by r. We can consider like this. Okay, so this is your angular displacement, and it is similar to the displacement but is in the form of angle. Note, some small angular displacement d theta is a vector quantity. Why it is a vector quantity? See, it has some direction. See here, for a very small angle there is a straight line, so this displacement is known as vector quantity. But a large angular displacement theta is called scalar. Why it is so? Because when you are traveling in a body is moving in a circle, so see here, for large angular displacement theta, every time angle is changing, every moment, every second angle is changing. So we can call this as a vector quantity when angular displacement is a vector, when it is theta or angle is very small. Okay, now it is a dimensionless and it has SI unit radian. So it does not contain, see, theta does not has any SI unit. So as we know that 2 pi radian, so this is your 2 pi means 2 pi radian is there. 2 pi means one complete revolution. So one complete revolution contains 2 pi radian, and this 2 pi radian is called 360 degree or one revolution. So for complete one revolution, the angle 360 degree, there is a 2 pi radian, and its direction is perpendicular to the plane of rotation and is given by right hand screw rule. See, let us consider a circle like this. Okay, so when angle is moving in a circular path, so we use the right hand rule. So our curl will give this direction, and this thumb, this is your thumb. Okay, thumb. So when this is your thumb and this is your curl, so thumb will give the direction of displacement. Thumb will give you the direction of displacement. Let us suppose there is a screw, right? There is a screw like this, and it is like this. So when screw is being turned in this direction, so what will happen? It will either go up or it will either go down. It means that when you are moving in a circular form, so an object is moving either in upward direction or downward direction. So I hope you have understood what is the direction. Okay, so the direction is perpendicular to the plane of rotation. Since this is your plane of rotation, this is plane of rotation, right? And if this is a plane of rotation and object is moving upward, so this is always perpendicular to the plane of rotation. Okay, so I hope you have understood now next topic is your what is time period. Okay, what is time period? It is the time taken by particle to complete one revolution, when it revolve for one time, so it is your time period. So time period can be considered as the inverse of frequency, where phi is the frequency. Now I will define what is actually frequency. So frequency is what? It is a number of revolution described by particle per second. For example, in 1 second it is moving one time, so its frequency is 1. But another object is moving how many times? 1, 2, 3, 4, 5 times in 1 second, so it has frequency 5. And another object is moving only half, so its frequency will be half, that is equal to 0.5. I hope you have understood. Frequency means number of revolution per second. It may be half, it may be 1/4, it may be 2, it may be 4, it may be 6, it may be 10, it may be something. So that is a revolution per second. In 1 second, how many revolution it took? Either it will be 0.5, 0.25, 1, 2, 3, anything. Okay, so I hope you have understood. Now I will talk about angular velocity. So it is very important. Angular velocity, as we know that linear velocity is denoted by b, so angular velocity is denoted by omega. So what is the difference between this? See, when an object is moving in a straight line, so it is your then the velocity with which an object is moving from one point to another, it is called linear velocity. But as here it is your angular velocity, it means that what is the speed at which it is moving in a whole angle. So this is known as angular velocity. So it is defined as the rate of change of angular displacement of a moving object. As velocity is your rate of change of displacement, that is dx by dt. So here angular velocity is rate of change of angle, that is equal to d theta by dt. Okay, so or the omega is equal to theta by d. Okay, so what is the unit? So unit of radian is theta is your radian, and unit of time is second. So its omega will have a SI unit, radian per second. Okay, now it is an axial vector quantity. Its direction is perpendicular to the plane of rotation and along the axis according to the right hand thumb rule. So as I have told you that this in any circular motion, so when an object is moving in a circular path like this and like this, so what will happen? It will try to move in upward direction. Okay, and if you will go reverse, so it will come downward direction. Okay, so this type of thing is known as axial vector, because it's acting along the axis. It is coming upward or coming back downward. Okay, by using right hand thumb screw rule we can use this. Okay, now I will talk about average angular velocity. So since average velocity you have also studied, that is already simple linear, just we need to compare linear so that you will be able to easily understand this concept. So here average angular velocity is what? Total angle of rotation divided by total time taken. So let us consider there is a circular motion. Okay, and from theta 1, it was theta 1 initial position, and it was theta 2, and time was initial was t1 and its final was t2. So total change in angle will be theta 2 minus theta 1, and total time will be change in the time will be t2 minus t1. And we can broadly tell change in theta by change in time. So where theta 1 and theta 2 are the angular position of the particle at an instant time t1 and t2. So this is the omega average. Okay. Now I will talk about instantaneous angular velocity. What is instantaneous angular velocity? What is instantaneous angular velocity? Okay. So see, it is the angular velocity at a particular instant. The word instantaneous means particular instant. We always talk about the particular instant. Okay. We always talk about particular instant, means very small time duration. Very small time duration. We will always talk about very small time duration. So when we will talk about small time duration, so it is the angular velocity at a perpendicular at a particular instant, that is omega is equal to limit delta t tends to 0 delta theta by delta t, and this is equal to d theta by dt. When we use d theta, because it is very small quantity, when we use time t, so its limit is time t tends to 0, so we can use this d theta by dt. So omega instantaneous can be written as d theta by dt. I hope you have understood now. So this is the instantaneous angular velocity. Okay. Now I will talk about angular acceleration. What is angular acceleration? The rate of change of angular velocity is called angular acceleration. Simply, rate of change of velocity is known as acceleration. Linear acceleration is dv by dt. So why not we will call angular acceleration, that is symbol, it is represented by symbol alpha. So alpha is equal to limit delta t tends to 0 del omega by del t, or d omega by dt. So alpha can be written as d omega by dt. I hope you have understood now. So this is known as angular acceleration. Now let us discuss about direction. So it is an axial vector quantity, and its direction is along the axis according to the right hand thumb rule. So its acceleration has also same direction, velocity as well as displacement is also upward direction. Okay. Now if a particle velocity will increase, then the direction of angular acceleration is along angular velocity. This is very important. If particular angular velocity is increasing, means acceleration is positive. So as per the right hand thumb rule, so if acceleration is like this, okay, acceleration is or velocity is increasing, it means that acceleration will be upward. And if velocity will decrease, then we can take acceleration as downward direction. So if velocity is decreases, then the direction of angular acceleration is opposite to the direction of the angular velocity omega, that is negative of angular acceleration. So this is your negative of angular acceleration, and the SI unit is radian per second. SI unit is your radian per second square, radian per second square. I hope you have understood these basic terms. Now I am going to discuss about the relation between linear and angular velocity. So you all have understood linear as well as angular, but we need to form a relation between these two both. Okay. So basically we will go for angle, that is theta is equal to del s by r. So this is very simple. Del theta is equal to del s by r. Just now I have taught you. Now del s can be written as r into del theta. Now divide the equation by delta t. So if I will divide this equation by delta t, so what we will get? So we will get delta t tends see here, del s by del t is equal to r del theta by r into del theta by del t. So if delta t tends to 0, then what we will get? So del s by del t can be written as ds by dt, yes, and r can be written as r, and d theta by dt. Can we write this? Definitely we can write this. So what is ds by dt? It is the linear velocity. So we can write like this. And r into what is d theta by dt? Just now we have reached to the conclusion. This is your omega. So what we have got? We have got a V is equal to R omega as a relation. We have got V is equal to R omega as a new relation. So I hope you have understood all. I hope you all have understood now. I hope you have understood now. Okay. Now V is square. Now since velocity and omega both are vector quantity, since velocity and omega are both vector quantity, so velocity is equal to omega in cross r. See why this is written omega cross r. See here. See, try to understand here. Velocity is in this direction. Okay. Shows the direction of velocity. So velocity is your this direction. Okay. And omega radius is in this direction. See, this is the radius. So by using right hand thumb rule, see if I will see, first of I will clarify it. See here. See, since axis of rotation has angular velocity is in this direction and radius in this direction, if I will do omega cross r, so you will get a velocity in this direction, yes or no? So this is actually velocity. Okay, this is perpendicular. We can see from this top view, we can easily see this is a dot is your omega. Dot is your omega, that is omega is coming upward direction, and omega cross r you will get a velocity in this direction. So that's why we have taken velocity v as omega cross r. So here velocity is a tangential vector because it is acting toward the along the tangent of the circular motion, and omega is an axial vector and r is the radial vector because r is acting along the radius. So these three vectors are mutually perpendicular to each other. See here, everywhere we can imagine. See, this omega is perpendicular to r and r is perpendicular to velocity. So all are perpendicular to each other. So practice particle circular motion is accelerated motion. So circular motion is your particular circular is accelerated motion. Why we are telling it is an accelerated motion? Because every time you will find that there is a change in direction. If change in direction happens, it means that velocity is changing, and if velocity is changing, then it means that it is an accelerated motion. Okay. So let us now consider what is acceleration. So acceleration A is equal to this acceleration, linear acceleration I am talking about. Okay. So linear acceleration can be written as dv by dt, or we can write here d in place of v is equal to omega cross r. We have written now like this. Now can we differentiate this? Since omega and r are different entity, by using differentiation rule of uv. For example, y is equal to in the form of uv is two variable. So first of all, I will differentiate d omega by dt and cross r, plus omega should be kept in a constant and dr by dt. Now d omega by dt is what? Alpha is equal to d omega by dt. So I have written like this, alpha cross r, and omega dr by dt is what? Velocity. So this is velocity. Okay. So this is your tangential acceleration, and this accounts for centripetal acceleration. As these both are acceleration only, linear acceleration. So linear acceleration is equal to tangential acceleration plus centripetal acceleration. So tangential acceleration plus centripetal acceleration. So why I have write is it as a tangential as well as centripetal acceleration. So it has some reason. Definitely I will show you some reason. See here try to understand. Here to understand, omega is in upward direction, alpha is also in upward direction, radius is in this direction. Okay, and acceleration is in this direction, linear acceleration is in this direction. So try to understand here alpha cross r. See, at this point, it is at this point, at this point we are getting two acceleration, linear acceleration, acceleration toward the center and acceleration toward the tangent. That's why we are getting resultant acceleration a as one tangential and one centripetal. Okay, so why it is your acceleration centripetal acceleration is written as omega cross b, since omega is like this and v is like this. So if I will cross omega, then what will happen? See here, if v omega cross b, so since omega cross b, so by using right hand rule, if you will do omega cross b, so what you will get? Omega, this is, see here, this is your omega is an upward direction and v is in this direction. So omega cross b, so when you will do omega and cross b, so what will happen? It will, as per right hand thumb rule, it will come toward this direction, that is center, acceleration towards center. So that's why I have taken omega cross b as a acceleration in a center, towards center. Now alpha cross r, since alpha is also upward direction, r is in this direction, so what we will get? Alpha cross r. So can you tell me alpha cross r, when you do alpha cross r, so you will get a quantity which is in this direction perpendicular to this. So this is what tangential. That's why acceleration is accounted for two type of acceleration, tangential acceleration plus centripetal acceleration. Here AT is the tangential acceleration and AC is the centripetal acceleration. Now here AT and AC are two components of the net linear acceleration. So if you go in a figure, so what you are getting? See here, you are getting two types of figures. See, this is your actual acceleration. So it has two type of acceleration, tangential and centripetal acceleration. So this is what about linear acceleration we have discussed. Okay, so always remember tangential acceleration is AT is what? Alpha cross r or alpha r sin theta. If in case if it increase, then what will happen? Alpha tangential will be plus r. If acceleration will decrease, then what will happen? Alpha tangential will be minus r. Now tangential force will be, just you do this, tangential force Ft will be what? Mass into tangential acceleration. If speed is constant, see in circular motion also, if speed is constant, suppose 30 meter per second, so tangential force will be what? Mass into acceleration, tangential acceleration. So in tangential direction velocity is constant, so it will be 0. But centripetal, in a centripetal acceleration won't be 0. Why? Because it is your m into AC. AC will always, velocity as direction is always changing, so centripetal acceleration will remain constant. Okay, so I hope you have understood this centripetal force. So centripetal acceleration can be written as omega cross b. See here, omega cross b, so it will always be changing, omega will always change, definitely. Okay, now I will give you some few examples. See here, force due to electrostat or force due to Coulomb force is known as force due to electron and proton is known as centripetal force. Any force acting towards center is known as centripetal force. A car is moving in circular motion, so what will happen? It will try to move outside, so a friction force will act towards center, and this friction force is known as centripetal force. Okay, So I hope you have understood now. If you are just you have taken a string tied with the stone, and if you move in a circular motion, so tensor towards center will act as a centripetal force. Centripetal force. Okay, so every time you need to understand that any circular motion we require centripetal force which must act toward the center, which must act toward the center. So centripetal is always perpendicular to the velocity or displacement vector, so work done by centripetal force is always zero. See, very important. If if centripetal acceleration is perpendicular to the velocity, so tangential velocity, so work done by the centripetal force is always zero. Okay, because it both work done is equal to force into displacement. Okay, on any curved path, not necessarily circular path, component of acceleration along v is tangential and perpendicular to v is known as centripetal. Let us consider like this. So it is along b, it is your centripetal acceleration, along b is your tangential acceleration, and at can be written as net acceleration can be written as tangential acceleration and centripetal acceleration. Okay, now centripetal acceleration is your omega square r or v square r or v cross omega. Centripetal force can be written as ms acceleration, centripetal acceleration, or mv square by r or mr omega square or mv omega. So these things should be memorized, and I hope I have completed most of the questions, or most of the topics I have covered in circular motion. I hope you will not face any type of problem. In case if you are facing any type of problem, just contact me. You can contact or you can also comment in a comment section, so that I will help you definitely. Thank you everyone. That's all for today.